Hello everyone, welcome to my channel. I am still looking at integration, and in this video I have this integral to look at. It's the integral of 5x cubed times the square root of 3x squared plus 5x to the power 7 dx. Now how do we approach this? Well, if we look at this expression here, we differentiate it, it doesn't give us that expression outside there. That means we need to do something else. And perhaps the first point of call would be to look at the expression under the square sign. We see there's a common factor of x squared there, so we can take that one out within the square root sign, and then let's see what we produce from there as follows. Taking us to our first page here. So what I'm saying is we have let's capture the integral. So we're dealing with the integral of 5x cubed times the square root of 3x squared plus 5x to the power 7 dx. So this is the same as the integral of 5x cubed times the square root of what I'm going to do here now. The common factor is x squared. Take it out. X squared into that term there, it's 3 plus x squared into that term there. Remember, when we're dividing exponential functions, we subtract the powers or exponents. So it will be 5x to the power 5, because 7 minus 2 is 5, like so. And then we have dx. Now, we can split this square sign here into two terms as follows. So what we have now is the same as the integral of 5x cubed times the square root of x squared times the square root of 3 plus 5x power 5 dx. You agree with me that that cancels that? So this is the same as the integral of 5x power 3 times x times the square root of 3 plus 5x power 5 dx. Nice. Now simplifying this part here, you'll agree with me that what we have is this is the same as the integral of 5x power 4 times the square root of 3 plus 5x power 5 dx. Nice. Now I'm going to do something here. I'm going to combine this term and that term because I see now that we can use U-Substitution. I hope you can see it very clearly there. When you look at the expression under the square sign, U-Substitution works perfectly now. So we're now going to say, let me move this page down so that it lines up with the page I'm just about to start writing on. Right. So what I'm saying to you now is that this integral that you see there is the same as the integral of the square root of 3 plus 5x to the power 5 times 5x to the power 4 dx. Nice. U-Substitution comes in handy now. I'm now going to let, but remember we have the square root sign, so we have to say u squared be equal to 3 plus 5x power 5. And we have to obtain two equations from this. The first one is to take the positive square root both sides. On the left we have u, on the right we have square root of 3 plus 5x power 5. This is the same as 3 plus 5x to the power 5 or the power 1 over 2. You'll see how important this one is at later stage. Next, we're going to differentiate both sides. You'll agree with me, if I may speed up here a little bit, you'll agree with me that we have 2u du on the left. On the right, we're going to just have 5 times 5 x to the power 4 dx. Remember, derivative of 3 is 0 because 3 is a constant. But differentiating this is what we have. And differentiating that part there, we have this. Simplifying and understanding that we have 5x power 4 dx. I need 5x power 4 dx. I'm going to have to divide by 5 both sides here. So I have 2u over 5 du is equal to 5x power 4 dx. Fantastic. Now this integral can be transformed as follows. I'm going to just put an arrow and say that integral now is the same as the integral of the square root of u squared times, instead of 5x power 4 dx, I'm just going to have this expression here, which is 2u over 5 du. Nice. I hope you can see that very clearly. This obviously cancels that. If we move on to the next page and just completing this now, what we have is the following. We have the following. Let me just put this one again in order so that it lines up with our second page here, page number 3 in our case. Right, so what I'm saying now is that integral is the same as the integral of u times 2u over 5 du. And taking 2 over 5 out as a constant, what we have is u times u, it will be u squared du. Using power rule, you'll agree with me that this is just 2 over 5 u power 3 over 3. Remember, we add 1 and we divide the result. This being an indefinite integral, there are no limits of integration. As you can see, no limits of integration. We have to say plus c, a constant of integration, and c is a real number. Now simplifying here, we have 2 over 15. Remember, 5 times 3 is 15. U to the power 3 plus c. But what is u? We have to revert to our original variable, which is x. If you check here, this is the expression I'm interested in. Where there's u, I must put that expression. So what we have now is, this is going to be 2 over 15. And if you like, let me use a square bracket here. So what I have inside there is going to be 3 plus 5x power 5. And the whole of this is the power 2, 1 over 2. Remember, square root is to the power half, that one there. But we have to raise the whole of this to the power 3 because you can see there's a power 3 there. And then I have to say plus c. Simplifying this, we get to the final step, which is going to be 2 over 15 times 3 plus 5x power 5 to the power 3 over 2, and then we have to say plus c as our constant of integration. So this is the final solution to our integral. Let me just remind you, remember we multiply the powers there to get this power here. The integral we have been looking at in this video is this one here. Let me just get the page. This one. We had to be clever there and work on the expression under the squared sign in order for us to be able to use U-substitution. So this is an example where U-substitution directly doesn't work. You need to do some algebraic manipulation for you to be able to see that U-substitution is the appropriate technique of integration that should be employed. All right, tell me what you think about this video, especially this integral we've been looking at. I'll be interested to hear what you think about it. What approach would you have taken in order to compute this? All right, I'll see you in the next one.